As we've seen previously, when the listener passes across the attenuation distance of a Sweej Ambience volume, the weight of that volume increases. If it's at a higher priority than other Sweej Ambience actors, then this will cause its resulting level to increase, while the resulting level of the other actors decreases. We can have a quick reminder of this. You can see here we've got a Sweej Ambience sound with a priority of 0, and we have a Sweej Ambience volume for the forest with a priority of 1. Now I'm just going to turn on the audio, and as we move across that attenuation distance of the forest, which is 1800 units, we can see the weight of the forest change, the resulting level of the forest change, and the resulting level of the global sound decrease. And we've also seen how this weight can be capped by adjusting the max weight value. So here the forest will stop with a weight of 8, and we'll still hear some of that urban environment blending in. These core underlying systems of priority, weight, and max weight are not limited to volumes. They can be accessed and used via blueprints in order to develop solutions specific to your needs via the Sweej Ambience component. In this level we have two Sweej Ambience sound actors, Global Urban and Global Rain. Since the rain is at priority 1 and the urban is at priority 0, when we switch the sound on, we'll only hear the rain. However, by accessing the Sweej Ambience component of the Sweej Ambience sound actor, we can dynamically control its weight, and therefore we can dynamically manipulate the resulting ambience. As an example, in the level blueprint we can get a reference to that Sweej Ambience sound actor, the Global Rain, and dragging out from that we can get the Sweej Ambience component. Then we can set its weight. As we set the weight, the principles of the underlying Sweej Ambience system still apply. So as the weight of this higher priority actor increases and its resulting level increases, the resulting level of any lower priority actors will decrease, and therefore we'll get a crossfade between them. This example will obviously switch between 0 and 1 immediately, but let's just hear it so we understand the principle. So selecting that Global Rain actor, we can see that its weight is 1 and its priority is 1, which is higher than the Global Urban, so we're only hearing the rain. When I press my debug key, it instantly switches, so the Global Rain now has a weight of 0, and the Global Urban is now heard. Let's adapt that a little bit so that it isn't such an instant switch. So here we're storing the component to a variable, and on begin play we're setting the weight to 0. Then we're using the rain current and rain target variables with an interpolation node to create a nicer transition between the raining states, and we'll see the weight variable being printed to screen. We might also want to take advantage of the other core principle of the system, which is that we can set the max weight for an actor in order to allow lower priority actors to retain some presence in the ambience. We can do that simply by assigning a max weight to the actor, and then in our blueprint we can get that value and use a min node. The min node returns the minimum value of its inputs, so even if the rain current float exceeds that of the max weight, the lower max weight will be output. This means that the resulting weight will never go over the original max weight value. So you can see there that the weight of the rain is capped at 0.8. To make this more adaptable, we can construct a blueprint component to add to our Sweej Ambience sounds, one that utilizes the SweejTech global parameter system. This means that we can use any named global parameter value to alter the weight of the Sweej Ambience sound. When added to a Sweej Ambience sound, this will get the Sweej Ambience component of the owner, the Sweej Ambience sound itself, and use the global parameter to set its weight. It also takes into account the max weight in the way that we just discussed. So now if I add this to my global rain Sweej Ambience sound and define a named global parameter, in this case I'm going to use global parameter rain, then I can use this parameter anywhere in the game and it will be picked up here and used to adjust the weight of this actor. For example, here in this weather controller blueprint, we're sending a value to that global parameter rain, to control the Sweej Ambience sound. And rather than sending it directly, we're using the rain current to read through a bespoke curve to achieve a nicer transition. The ability to access the Sweej Ambience component of any Sweej Ambience actor, or add this Sweej Ambience component to any other actor, while still utilizing the core Sweej Ambience systems of priority, weight and max weight, opens up a range of possible bespoke solutions that you can develop according to your project's needs.